Well, good morning and good afternoon, everyone. Welcome once again to Beyond Compliance. My name is Aaron Bolshaw with SafetyChain Software. I'm the moderator of Beyond Compliance. And if you are joining us for the first time, Beyond Compliance is a periodic industry update for process manufacturers. The goal is to bring you insights around the market that shape the way we grow our businesses, deliver quality products to customers, mitigate that supply chain risk, and also safeguard our brands. All of this while, of course, improving yields and maximizing productivity. And we've got a great discussion today. We're talking about proactive maintenance. That definitely goes into that productivity bucket. So if you want to advance the slide there, the webinar series is sponsored by SafetyChain, the #1 plant management platform, uniting compliance, safety, quality, and production. And if you advance it one more time, I just want to make sure everyone understands that we cannot hear you, but we do want to hear from you. So with questions, we're going to save those to the ends, but please look at your webinar console on the right side there. You're going to find a little button with questions. As we go through the presentation, just type us some questions. We'll save those to the end, and we do want to hear from you because we do want to help you. So with that, the recording link and all of that stuff will be shared from our, if you need to or want it, excuse me, from our presenting team at People and Processes. So with that, let me introduce you, if you will, one more slide here. Jeff Shiver is the founder of People and Processes Inc. and a true legitimate expert in maintenance engineering, and he's held a lot of operational positions within Mars, Procter & Gamble, IBM, you name it. So he's level 2 and 3 certified, and he is the past director of member services for the Society of Maintenance and Reliability Professionals. Chances are he's probably been in your plant once or twice in his career. So he has also authored a book, Kiting and Maintenance Made Simple, which is fantastic. And he is also a columnist, Plant Services Magazine, From the Plant Floor. And I am super happy to have you on Beyond Compliance. Welcome, Jeff.
Thank you so much, Aaron, as well. And as part of that, one of the things we'll do today is we'll talk about a lot of different opportunities. And I wanted to share with you very quickly with regard to People and Processes, quick intro. You learned about me. Here's People and Processes and all the different things we do. One of the things that I'll bring your attention to is kind of to the left side there, the certifications. We partner with the University of Tennessee Reliability and Maintainability Center. And with that, we offer different certifications overall. And there you can see with all the different things, but obviously if you'd like more, you can always go to peopleandprocesses.com. That's it. Today, I'm super excited to be here with you. And this webinar presentation itself is actually an offshoot, a derivative, if you will, of an article that I have in the column. I have a column at Plant Services where I provide monthly articles. And actually, there's another place in Plant Services, if you find it, do a search for Ask Jeff. There's a blog that's really not linked, but there's a blog out there that is a couple years old, but still the material is just as relevant today as it was then, where people ask questions and I responded to those. So another thing at Plant Services. Also on YouTube, you can find at the People and Processes channel, you find a ton of videos too. So, but today, what we want to focus on is we talked about proactive maintenance, and some, obviously proactive maintenance is a very big subject, and we can spend just days and days and days talking about all this great stuff. Today, we're going to focus, okay, what do we need from a business standpoint? Our responsibility from the maintenance perspective to educate others, our partners. And notice I said partners too, I didn't call them customers. And we'll talk more about that. The right maintenance, the right way, the right time, and building trust, from the planning and scheduling perspective, and addressing failures. So let's get started. So hopefully you can identify some of these in your world. Well, I should say, ideally it'd be better if you couldn't, but that's not reality for us. And so as part of that, how many of you think about this? How many of you have a partnership, a true partnership? What do I mean by that? Well, you get access to the equipment. You have a weekly scheduling meeting, hopefully, and production or operations attends the weekly scheduling meeting. You get to talk about where you're going and where you've been, and you talk about maintenance metrics. As an example, I was in one site, and it happened to be a mining organization, and the maintenance manager had spent 10 years cultivating a very proactive organization and trying to do all the right things. And they got a new production manager, new operations manager, and that individual says, that's all great, but my job is to make product. And I could care less about your metrics. I could care less about your program. And it's funny how, you can change management, for example, and just the whole world seems to just blow up. And the challenges, we talked about education, we'll get more into that. And then with regard to that, how many of you deal with no access? It comes back to the partnership thing as well, but how many of you deal with that? Okay, we want to be able to work on this particular piece of equipment, but we just never can seem to get time to get there. Production's always running it. They're running over in some cases because it's not reliable. And we get into that scenario as well. So I'm sure many of you can identify with that. Some of you might be fortunate where you have specific days down and you're able to get access to equipment, but that's not everybody. And this other piece too, we talk about, having time, but it's also having the resources. And part of that challenge is with regard to technicians, having really knowledgeable and skilled technicians. And if we talk about one organization that we work with, actually more than one, they've had turnover like 42% in the last 2 to 3 years. And that's huge, and if you think about it, if you don't have good processes and good procedures, and you don't have a mechanisms like skills development, matrices, for example, to how you train people and how you spool them up to be able to do the job, becomes really a challenge for you. And so with regard to that, how do we balance time and money? And what do you mean by that? Well, okay, so if you look at those partners we talk about, those executives, and one organization was really funny. The executives, they're like, that's great. We understand you want to do maintenance, but we need to make product, and we're going to go do that. And at some point, they're willing to accept the risk. And to talk a little bit more about that, well, I'll talk about that in just a second, more so with another slide coming up. But the challenge gets to be is how do we make sure, I mentioned early on, I said, we don't really think of the operations group or other groups within the sites as our customers. And with regard to that, what happens is maintenance, if you look at different studies, maintenance only owns about 17% of the asset reliability. Other groups own more and some own less. But when we talk about that, are we all headed in the same direction? And that really brings me up to this next piece. And with regard to this, I want you to think about your organization, and I want you to think about the maintenance function and how it interacts with those other groups. And do you get access? Do they participate in the weekly scheduling meetings? Do you have a daily planning meeting or scheduling meeting, where you talk about, okay, here's what happened in the last 24 hours, but this is what we're going to do today? It's still part of the larger bucket, okay? And is it about assigning blame, or is it really about all of us heading in the same direction? And think about as well, how frequently are PMs, for example, delayed, or access to the equipment? So for that, I want you to really answer a poll question for us, okay?
Yeah, and I'm going to bring this up for us, Jeff. That's amazing. 17% of asset reliability. That seems wildly off. Is that? It seems that's very low. Is that your opinion?
Yeah. So it's interesting because when we talk about that, the 17% was actually done in a forest products company, and it was published in Keith Mobley's second maintenance engineering handbook, second edition of that maintenance engineering handbook. And they actually list that engineering owns the largest share. So obviously, if you design it incorrectly, you don't install it correctly, we're already suffering, and typically you think about, with regard to that, the engineers are sometimes like seagulls. They fly in, they drop off a load of stuff, and then they turn around and fly off. And maintenance and operations has to deal with that. And then the next group behind that is like operations. And if you think about it, no matter how well you maintain something, if operations operates it incorrectly, no maintenance in the world can keep it running. And then even, so then you hit maintenance, and then below that you have sales and marketing. You might say, wow, how does sales and marketing impact this? Well, think about this. hey, we're getting ready to take a shutdown. And this was a true story from a mining organization in Central Florida. You're ready to take a shutdown. Hello, yes, sales and marketing. You can't shut down. What do you mean? We've been planning this for 2 years. Sorry, we've sold everything you can make, and your sister site is not running well. And so that's a good example, and I have many more of how sales and marketing impacts the maintenance activities or the reliability of the assets. And then even think about spare parts or procurement, or how the management organization sets you up, and how they choose to operate the plants. All those things are factors. And even Ron Moore, in his work, he identified that maintenance actually owned 10% of the overall equipment effectiveness, OEE metric, only 10%.
That's amazing. All right, this is great. Okay, so let me start this poll, Jeff. We're just going to set this up. Everyone's going to get this. We want you to answer honestly. Just we're not taking your names. Just this we'll show everyone the results at the end of this, but nobody's name. So go ahead and start voting here. What is the role that the maintenance has with other groups or departments? Think about equipment access, scheduling, etc. So is there no partnership? Is there like a negative or almost no involvement? Right? Maybe a little bit of partnership there between those. How about you have good partnership, right? You're involved when needed, or do you have this, as Jeff calls it, this true partnership, something that's really proactive. You're sitting down, being more strategic about these assets. We got about 50% voted so far. Keep it going. A couple of you still not thinking of maybe what you want to put there. A couple more people, and we'll close this poll in just a second, Jeff. I'd love to get your thoughts on what you think of this. So I'm going to share the results very quickly. And what do you think?
Yep. Can you share them with me? I actually cannot see them.
Oh yeah, so I'm sorry. As we do this, so it's actually 0% says no partnership, which is great. Okay, so that's fantastic. A lot of people on the webinar, and nobody's reporting no partnership. We got 25%, 1 out of 4 people saying some partnership, 43% report good partnership, and 32% true partnerships. That's a pretty good bell curve in the right direction I'd want it to be, right?
Yeah, absolutely. And I'm so pleased to see that among the audience because it's interesting. Where I was at just literally a few weeks ago, it was actually, it would be the first answer in that pile with no partnership. And it was interesting because maintenance would actually come and just shut down equipment and take it away from the operators. And at the same time, the operators, it was just all the way from the top down. There was just a huge opportunity. So it's interesting to see the dynamics. And I'll share with you one of the things that we did, even in my background. We had to put together a team, and I'll talk a little bit more about that in the education side, to where we work together to figure out, okay, how do we actually choose to operate the facility together between production and maintenance as examples, and forget all the higher level executives and the plant manager and other people. It was simply, how are we going to work together? And it's not about, unlike where I was at a few weeks ago, it's not about assigning blame. It's actually understanding the true root causes for issues and how do you overcome them. Yeah, good.
Thank you, Jeff.
Thank you. And so when we're talking about this, and we were talking about choosing risk, and I mentioned, one of the individuals I talked to previously, just a few months back, he was sharing with me, he said, I'm trying to get executives to buy in to giving me access to the equipment, and I can't seem to make that work. And it's funny because it happens that the corporate reliability manager, I should say, actually left like 7 months prior. And the reason for that was he didn't get support either. But when we talk about actually choices and how does maintenance respond to that, if we look at this chart, it talks about ideally proactive cost. If you followed up, we detect misalignment starting on the very left to the bottom left. And then with that, we do some level of realignment. And if we can do it, our cost is very little. And then as we continue on, we start using, the vibration again, and we find that the bearing's damaged and we have to replace the bearing, and our cost here, $2,000 or whatever the case may be. And then, if we don't do it, then we continue on up the curve and we get into all the secondary damages. And for us, for maintenance, that looks horrible. But when we think about this, and we have to ask the question from a business perspective: what risk are you willing to accept? And you could say, yeah, ideally we want to be back here and just do the alignment right to start with, and we'll never get into these situations. That's always the better choice. But sometimes we're not successful doing that, and then we get into issues. And we'll talk more about early mortality, or what we call infant mortality. We'll talk about that in just a minute. But anyway, the challenge gets to be, if I'm a company and I can either choose to accept $23,000 in risk to make potentially millions or exponentially more than the $23,000. And so they're making choices. And so, for example, with a forestry organization, as many of you know, if you've gone to buy a piece of lumber at the hardware store, the prices are just out of this world, it seems like. And they're making so much money that they're willing to accept the risk. And in one particular organization, we work with a lot of different forestry groups, and one particular organization, they actually realized, they said, okay, we know we're probably going to lose this major piece of equipment, and we hope it doesn't shut down the mill, but we're going to accept the risk. And unfortunately, they didn't survive. They got caught, and they had to go in and spend the millions of dollars to fix it. And it took them down for 60 days to be able to do that. But again, it was a business choice. And that's one of the challenges we have in maintenance, is to understand, we just can't seem to understand, okay, well, we want to be able to do the right things. We're trying to do the right things to make sure that the lines continue to operate. If we think about this, there's we can think about it in terms of can versus want, And what do you mean by that? Well, what is the want? Let's say the want's 100 gallons per minute from a pump. Well, what's the capability of the pump? Maybe it's 120. Well, maintenance lives in between that can and the want. Maintenance actually has to own the equipment. And as part of that, there comes those decisions to accept the risk as part of the equation. And so where do we go from here? Well, one of the first challenges is we have to think about, how do we set up education? How do we paint a picture for these individuals to say, okay, this is what the impact. We want to arm them up with the knowledge and information to make the right choices. And it's not to say that we're not going to lose out in the end and get into a broke fix scenario. We very well may do that. But again, it's about the business choice. And so with regard to that, I talked about earlier, one of the things we had to do is we actually put together a team, and we would meet every 2 weeks, and it was a combination of operations and maintenance. And we would talk about, okay, how are we going to actually operate the facility? And how are we going to get access to the equipment? And how are we going to do the different things? And it gave them an opportunity to educate us on what their requirements were. At the same time, it gave us an opportunity to educate them. So that's the partner aspect of that. And with regard to that, then you think about it, there's also the maintenance aspects. And it's crazy because I go to so many different organizations and I'll find planners. For example, one that comes to mind, they had 12 planners, been in the role for 7 years, no education at all. And I frequently find that. And sometimes it's even so bad that you'll find where for example, like a planner was told, basically go buy the book, and yeah, while that's better than nothing, that's still not the same. And when we talk about that, what does that really look like? Well, first, you have ignorance, and then you have some level of awareness when we talk about the different phases of the developmental journey. And at some point, you want to become literate, and that's the training piece. But recognize the training piece is only half the education, at best half, okay? And the other piece is basically coaching. And the coaching is where somebody walks right beside you, walks the mile in your moccasins, literally, attends the daily meetings, goes to the weekly scheduling meeting, and points out these opportunities and how you improve, and coaches you, for example. And I'll give you a quick example. I was at a site, and they had hired a new planner. And I knew he'd been in the position about a month. And I went to him and I said, hey, show me your schedule. And his answer was, well, I've been really busy trying to learn the software and so forth, and I really haven't produced a schedule. I said, okay. And I said, well, show me some of the job plans you developed. And well, I told you I've been busy with the scheduling software. And we kept talking, and I realized in the conversation, I said, you know all the lingo, but you've never actually developed a corrective job plan, have you? And he said, no. And I said, okay, let's roll up our sleeves. Let's go out in the field, and we're going to develop a couple. And that's exactly what we did. So that's a good example of the coaching. And the challenge there is now we're able to. And if we think about this, this is one of the benefits of certification is we talk about what's your competency. And one of the things that we do is when we have, for example, we do coaching for planners and others, is we actually have competency matrices. And with those, what we do is we basically, if you will, evaluate the skills and knowledge of the individual. And we say, okay, we believe based on this matrix, you're at this particular point. And then maybe you need another coaching visit or something. We get you up to where you're very competent in that. And that's really the challenge for organizations is how do we build a competency? And certification validates that knowledge. Okay? And the second point is how do we do the right work at the right time in the right way? And I've shown you here, this is called a conditional probability of failure curve. If you're not familiar with reliability-centered maintenance, it actually started, there was a report written in 1978 by Nolan and Heap. And if we back up to when actually the process began in Maintenance Steering Group 1, we were having 60 crashes per 1 million takeoffs. And this was in the late 1950s, early 1960s. And we had the L1011, the 747 on the drawing boards. And I think it was actually 1978, if I remember correctly, where the 747 came out. But at the time, we were having 60 crashes per 1 million takeoffs. And in today's terms, this number might surprise you, but it would be equivalent of 2 747s per week crashing. You probably choose not to fly, and that would be understandable. The risk is simply too great, intolerable risk. And so what happened is the FAA got involved with the Boeing, for example, the Department of Defense, United Airlines, and they put together Maintenance Steering Group 1. But as part of that, what the manager said is, okay, we'll tell you what, we've been doing overhauls, for example, at like 6,000 hours. What if we change the frequency? Let's do them at 4,000 hours. And they did. And my question to you is were there any changes in the rate of crashes, 60 per 1 million takeoffs? And the answer is really no. And it was interesting because United Airlines, for example, they had looked and said, okay, we have certain failures that are random and some are age related. And they got surprised because with regard to that, I should actually say many were age related. And they got surprised because they found out that things they thought based on age actually failed more randomly and vice versa. And so with regard to that, there's really a key message in here with it, because what happens is more maintenance does not mean better maintenance. And that's a key takeaway for all of us. It's not about doing more and more maintenance. It's about doing the right maintenance in the right time in the right way. And Winston LeDay probably put it best in his book, Don't Just Fix It, But Improve It. He talks about 3 domains: the reactive domain, the planning and scheduling domain, and then the precision domain. And with regard to that, many of us have come from reactive domains, and we're trying to get to planning and scheduling. But it happens that planning and scheduling by itself is inherently unstable. And so with regard to that, it's not about planning and scheduling more work. It's about eliminating the need to plan and schedule work. We still have to plan and schedule work, but how do we eliminate defects? How do we keep these recurring failures from happening? So again, it's not about planning and scheduling more. It's about eliminating the need to do the work to start with at that level. And interestingly enough, out of reliability-centered maintenance, we learned that the pattern F, and there are 6 patterns, by the way, and you can do a search if you're not familiar with reliability-centered maintenance. You can look up curves. There'll be 6. And 11% of failures in the aviation side showed that they were time-based or had some wear-out component. What we're saying is we're not saying that things don't wear out. We're saying there's a pattern where most all fail about the same time for a given component based on a specific operating context. Now, that said, what we know is out of that 89% fail randomly. They didn't really have a pattern. And think about, when an operator operates something incorrectly, or when we don't do the alignment, or we hammer on a bearing with a brass punch, or we take a torch to heat it up when we install it. All those things create failures. And with regard to that, we've talked about pattern F. It's simply infant mortality. And with regard to that, about 70% of items, 70% fail early. And you might say, okay, Jeff, but one of the challenges we have to think about is just simply doing intrusive maintenance. where we go in and open something up or take it apart or whatever, and then reassemble it just to check something or overhaul something, just doing that intrusive maintenance itself disturbs an otherwise stable system. And that in itself can create the failure. And these failures come from poor design. We didn't clean the assets. We always say that cleanliness is next to godliness in so many ways, because if we can keep it clean, that solves a lot of heat issues and, grit, contamination issues and so forth, improper operation, parts from the storeroom. How many times do you have MacGyvers that, okay, you don't have the right part, but you just figure out some way to make something else work, or you patch something together and Band-Aid it? How do we make sure we do it right the first time? And so we talked about, roughly 70% self-induced failure. And Winston LeDay in his book, he talks about 84% of early failure. 84% of failures are early failures caused by poor work habits. Okay? And so when we talk about fixed intervals, it's interesting that we think about maintenance in many cases. It should be primarily an inspection, and for many of it is, but in some cases we still overhaul way too frequently, and we replace items and we don't really understand the condition of which we actually need to do that. Okay, and we introduce the infant mortality. So when we talk about maintenance strategies, ideally, if we could pick the best choice, we'd go after reliability centered maintenance. And you may say, Jeff, that's like the resource consuming monster. And what I'll challenge you with that. And the reason is because if people are properly trained and they understand how to facilitate groups, there are 45 competencies for facilitators, as an example. And, I've never seen groups that were properly trained and properly coached talk about it as a resource consuming monster. Okay. But even if you're just going to do PM optimization, you still have to understand the failure modes. And I always encourage people to take an introductory course in reliability centered maintenance, even if you never intend to do an analysis. The reason is because we want to be able to understand the framework, and then we can make the right choices. And for example, deal with the functional failures and failure modes, because just PM optimization, we have to understand the failure mode. And then from that, we can pick the right strategies. And continuing down the list, based on risk, we pick failure modes and effects. But remember, failure modes and effects in many ways is based on a number, severity, occurrence, detection, and can be subjective. And many organizations try to streamline it. And whenever you hear the word streamline, it simply says something was left out. And there's a risk associated with that. So we call it a lower order. And PM optimization, clearly there's an opportunity. And you'll see it in just a second with regard to the number of PMs that don't add value. But we still, as we said, still got to get to the failure mode. Then obviously the next level is something the OEM manual, and you'd be surprised how many we take from the OEM manual. And they're really not written to a specification, if you will. And I'll explain that. And then obviously we can choose to do nothing. And that's a legitimate choice. But no schedule maintenance is not the same as run to failure in many cases. We can plan for the failure. We just don't schedule it, okay? And so that brings us to this piece here. From RCM analysis, we know that 40 to 60% of PMs add no value. So you think about it, I could ask you right now, just sitting at your desk or wherever you're at, raise your hand if you could use more technicians. And the majority of the people in the audience would raise their hand. And what does that mean? Well, think about this. You send technicians out and you have them execute these PMs, but these PMs don't add any value. And as an example, I was in Maryland, and I was doing an FMEA, failure modes and effects analysis. And with that, we took out across 3 partners, we took out 1,015 PMs that somebody had to touch across the course of a year that didn't add any value. And what happens is production, for example, will say, hey, we had this failure, put a PM on that. And somebody will put a PM on it. And oftentimes they won't even combine it with the other PMs, and they won't look and say, is that something we could even address? For example, like a valve was left closed. Well, a PM's not going to solve that. Are you going to do that PM? Are you going to check for that valve position every time, every day, every shift? No, it may be something that was following a maintenance intervention. And if that's the case, then yeah, we could add a line to the PM to say, hey, make sure you leave the valve in open position before you walk away from the job. That's fine. Okay. But realize that again, 40 to 60% don't address the likely failure modes. Okay. So we send those resources out, we consume them, we get nothing for it at the end of the day. And oftentimes we don't have a good process to even update the PMs or root cause analysis to drive that. And we'll talk a little bit more about that. So when you think about your maintenance strategies, so your PMs, by the way, time-based overhauls, for example, ideally top tier organizations are around 20% or less of their work. Think about condition monitoring, which can be inspections and predictive tools, for example, vibration infrared ultrasound, oil analysis, motor circuit analysis, some of the big five, and even the operators doing minor maintenance activities. Okay, so with that, answer the questions with regard to the poll.
Yeah, so I'm going to pull this up again, and again, same process, everyone. I encourage everyone to be, transparent, honest. We're just going to pull up this poll really quick about how you'd rate your maintenance strategy. I want to make sure I get the right one in there. Yes, okay, got it. I'm going to launch this. And Jeff, on the screen now, they've got it. It says, how would you rate your maintenance strategy? I.e., is it PMs, PDM, and operator-driven reliability? You get three options here, folks. Select one. Just most of our PMs are basic, right? Maybe you're kind of in the middle of the road. You're sort of in the, just neither, outstanding work, world-class, nor are you a laggard, right? Or, do you have your PMs? Are they mainly condition-based? Okay, so we've got about 28% of the people voting so far. Pick one that best describes where you're at. You may not have it. It might be kind of somewhere in the middle of those, but do your best there. And it's interesting. While we're doing this, the pre-op inspection, you're talking about, hey, is this valve open or closed or something like this? I've got a really interesting question for you while this is going. Pre-op inspections, where do you see this belonging more, right? Is it that operator? Is that operations? Or do you see maintenance walking that floor too? Is that one of those partnership areas, Jeff?
Yeah, so it's a great question. And I like to come back to the operation side. And I'm reminded of an operator that I met a few years back. And he told me, he says, Jeff, he said, it happened to be an organization that did tooling. And they press cans and bottles and other things. And as part of that, he said, Jeff, what separates me from the other operators is I come in 20 minutes. Well, when I start my shift, I spend 20 minutes. I shut my machine down. I spend 20 minutes and I go through my piece of equipment. I own it. And he says, I make sure that everything's set up properly, the whole 9 yards, and then I start it up. In contrast me to the other people in the room, what they do is they come in and they just, they never seem to shut the machine down. And then when they first arrive at the machine, they might do a quick debrief with the other operator, and then they'll just continue running, or hit the start button or whatever the case may be. And he said, what happens is they struggle the entire shift, and they're up and down and they can't produce a quantity. And he said, I just run, he said, I'm able just to run. And so I really think it's important. I go to so many organizations where operations doesn't take ownership of the asset. And, they might put in a work order, for example, and then they go off to the break room while they're waiting on the maintenance person to come over there. And if you think about actually owning the equipment, the operator standing right there, hey, what are you doing to my machine? I want to watch you do this. Let's talk about, how it's acting. And then, hey, well, no, you can't leave yet. Let's make sure this runs before you walk away. And that's what we really need, is that operator ownership. And, it happens that in many cases, if we go to the operation side of the house, they don't have skills development matrices either. And, they don't necessarily have a lot of formal training for people operating machines. And it's a huge opportunity in many organizations.
It is. It's just being curious, right? Why would you go to the break room? I love that. All right, Jeff, we've got some results from the poll. I'm showing them. It's kind of across the board. It's about 1/3 of people say most of our PMs are basic. Just a little over half say middle of the road, right? And then we got 12% out there saying they're mainly condition based. Any thoughts on that spread?
Yeah, I'm not surprised. I actually asked the question one time at an SMRP conference, and I had probably 200 people in the room. And I said, raise your hand if you feel really good about your PMs. And the majority of people, as a matter of fact, all except for one, kept their hands down. And I said, okay, now raise them up. I was really pushing them to drive the engagement and to get them to raise their hand if they felt good about it. And just that one hand stayed up. And he put his hand down when he looked around the rest of the room. And I said, wow. And so he came up to me later and he apologized. And I'm like, why are you apologizing? He said, no, I said, we've just recently gone through our PMs. We've done all these great things. And I said, well, don't apologize. I said, that is fantastic, but it is very common. And when, and one of the things I probably should have said before we even did the poll is think about, do the tasks on the PMs indicate failure? So in other words, do you find the failure or do you find the potential for failure? And that's what we have to look for. When we talk about the PF curve, and you can look that up on the internet, but it's infamous in many ways, but to use the PF curve, the distance, it has to be relatively consistent and there has to be time to do something about it. So with regard to that, what we're looking for, I used the example earlier of 120 gallons is the capacity and the want being 100 gallons. But when can we find it? Well, anytime it's dropping off 120, we find it. But at what point do we want to take action? Well, maybe you said, okay, Jeff, 104 is a good number for me. And so what happens is we're going to put a work order when the operator gets, when they read when they do their rounds or their checks or whatever, and they read it's 104, we're going to generate a work order. And that tells me I'm finding in the act of failing. And so, for example, using another example, chain stretch. If I'm on that same partner I talked about previously, and the distance between 4 buckets, when the chain is new, is 72 inches. But when the chain is actually wearing and we hit that P, it's 72 1/4. And then when it's actually functionally failed, it's 72 3/8 inches. And so the challenge for us is how do we find the P, not the F? We don't want to find the failure because it's too late. We want to find the potential for failure, which gives us time to plan and schedule it, get the material or plan it, get the materials in, schedule it, and do it when it's convenient for the operation and restore it to like new. And that's where maintenance lives, in between the can and the want. Okay, so yeah, and so it's really important. And many times when we talk about even the OEMs guidelines, they don't give you those specifications. Like that number I just gave you with regards to that chain stretch, that came from a service technician. And I had to hunt down the actual report from the service technician to figure out the different points that they would say that particular component was approaching failure and it needed to be replaced. And that's really the challenge for us, is how do we find that? What determines the P that gives us enough time to plan, get the materials and schedule it and restore it to like new before it functionally fails. That's a key piece, and that's what your PM should be designed. Don't look for the failure, look for the potential for failure. Well, so good. All right. So the third tip I give you is let's improve our estimating accuracy. So if I go, for example, to a bottler, and the bottlers, you go to maintenance people in the plants and they tell you, well, we just can't get access to the equipment. And I go to the corporate production planners, they're sitting in the national office, and I say, hey, maintenance tells me they can't get access. And they said, no, we'll give them access. They just need to tell us what they need. And they said, as part of that, we need some agreements. This is the partnership piece coming back. They said, we need some agreements. So what we need is you tell us what you need. Don't tell us you need 24 hours and only take 12. That won't work. And don't tell us you need 24 hours and take 36. That won't work either. And so one of the challenges that I find in many organizations is we're not very accurate with our scheduling. And what should happen is the planner, ideally you have a planner and you have a template that looks something like this. We call it a walk down template. And the planner spends time in the field and they go out and actually walk down jobs. And you'll see it, they should spend a third of the day in the field. And when they're walking down the jobs, they're looking and saying, okay, what are the task steps? And it would surprise you, this builds what we call a corrective job plan. And this lives just like a PM would live inside your system, but this is unscheduled. It's only attached to the work order or scheduled out when we actually need to do the work based on some prior inspection or something. But the planner goes and physically walks it down, what's necessary, what materials are needed. And when we break it down to these task steps, we can determine the number of technicians or personnel we might need, the time that's required for each step, and then our total time with regard to total hours spent on it. But the job duration is what's key. And by doing this, we can come up with a much better estimate. What I often find organizations doing is a planner or somebody else will estimate, well, it's a half a shift or it's a whole shift. And reality is it only takes 2.5 hours. And we need to and realize too that every technician is going to be different. So we estimate 2.5 hours. Well, one technician might do the job all the time and they can do it in 2 hours. Another technician might not do it that frequently and does it in 3 hours, but the average is 2.5. Okay, fine. That's what we're trying to target because we can improve our accuracy. Plus, it makes sure that we're scheduling enough work to the technicians. And we've done things like wrench time studies in the past. And with wrench time studies, in one organization, we would find that they drifted back, the technicians drifted back after the afternoon break back into the shop. And we were trying to figure out why that was. And what was actually happening was that the planner was given, was asked to estimate the job before they agreed to do it. And this is on all the jobs. And they would estimate it. And then the process was set up in such a way that there was a reapproval process. So if the estimates varied by more than 10% with regard to the actuals, had to go through the reapproval process. So that means for a 30-cent O-ring and an extra hour worth of labor, we're going back through this reapproval process, which was insane. Be careful what you ask for. You just might get it. And so what was happening is that the planners were overcoming that by overestimating the jobs. And then what would happen is we weren't assigning enough work to the technicians. And it's not about, we're not trying to make the technicians work harder. That's not the point. We're trying to fill up their day and trying to get more work done. That's really the challenge. And most technicians that I work with, they'd rather be busy. You know, that's what they're really after. And
Yeah.
so we talked about the planner spends a third of the day in the field, and we look for the planner accuracy to be plus or minus 10%. Now, you might read in a book out there, my good friend Doc Palmer says plus or minus 100%. And yeah, you're going to have exceptions, but on average, you know, 10 to 15%. And that's one of the things we measure individuals. We measure the planners individually. For example, another tool for measuring the planners, less than 5 days in the planning queue, the planning status on average. And then another tip for you is that, you know, let's plan the work. And so here you see sort of a simple planning process. Just, you know, there's many steps to it, but here you just see a bulleted planning piece. If we need materials, we get the materials, we kit them. Okay, and by having them sitting there on the ready, they're available to us. And so if we get into breakdown situations, we can pull those forward. And so those go into the ready to schedule backlog. And I want to mention something here too. It's planning, then scheduling. It's not planning and scheduling. It's planning, then scheduling. So what do I mean by that? Well, everything that's in the planner's queue, the planner should just be sitting constantly churning out job plans if they're necessary, getting the materials identified, making sure that they get kitted. Ideally, your materials management storeroom function is doing the kitting. They're stored in the storeroom. But anyway, and then we change the status to ready to schedule. It goes into the backlog. And from that backlog, the supervisor has to have some knowledge of that. And so, you know, what's in the queue for this week? What are we doing this week? What's our bucket of work that we're attempting this week? But then also, what's also in the backlog? So if I can't do this particular job this week, I can pull something else in. I'm not going to get credit for it from a schedule compliance perspective because we didn't put it on the schedule before we started the week, but I'm still getting more work done. And so if a piece of equipment becomes available, we have some breakdown, then we obviously have to deal with the breakdown first. But if we have other resources that, for example, are just monitoring other lines or things, let's bring them over and let's pull some of that ready to schedule work that's already kitted. So all the parts are sitting there, and let's see what else we can do while we've got that machine down. You know, maybe we're going to have to change a bearing. It's going to take us 4 hours to swap the parts and pieces out. What else can we do? Is there a PM we can knock out? Is there some other small corrective work we can knock out while we're down? Let's focus on that. And that's how we get access. And there's actually an article that'll be sent to you that is around 12 ways to find time to do maintenance work. And it's part of the conversation we're talking about today. And then I want to share with you the big picture. And I call this the big picture. Ideally, we're starting up here in the RCM side, we have some mechanism to choose a strategy. And from that, you know, with RCM specifically, we're going to have proactive tasks. We're going to have changes to how we operate or maintain the asset from either training or procedures perspective, or in some cases, we might not can even solve that. You know, we might have to re-engineer it because it's just a really bad design or something else. You know, maybe the common theme that I hear is, well, it used to be, Jeff, 120, but now operations wants 130 gallons out of that pump. Well, guess what? We can't do that. We can't get there from a maintenance perspective. So we've got to re-engineer it. And that's what that's really about. But we take these proactive items up here in the top, the proactive maintenance tasks that you've written to a specification, gaps, fits, torques, tension, belt tension, what indicates that potential for failure. And then we enter those into SafetyChain as an example, and we workload level them. And then from that, we build a schedule. And these are the PMs, the PDM activities, the inspections, and we put those into a schedule, and then we coordinate if we need trades. For example, we might have to have scaffolds built for us or something else, and we coordinate. And we often don't talk about it in terms of planning, then scheduling, but it's planning, then scheduling, and it's part of that coordination. We don't talk enough about coordination. And then we execute the work. And then the question would be, think about this, how many of you have a feedback loop? How many of you have a document that says, okay, here's how we improve the PM, or here's how we improve the job plan? And yeah, you might say, well, we sort of expect the technician to put that in the notes, but then who reviews it? So how are we constantly looking to improve? And so that's that feedback form, if you will. And then we plan those jobs that require follow-on work. We found this in the act of failing from the inspection. Okay, well, let's proactively plan and schedule the repair. And when we talk about that, realize we want to be 90% plan, 10% reactive. 90% plan, 10% reactive, okay, from a world-class perspective. So we want to push everything we can into the planning realm. And then we build reusable job plans. Maintenance work is repetitive. Today I work on this pump, 6 months, 2 years from now, I'm gonna work on it again. Why do I need to reinvent the wheel? I just pull out this job plan. It goes in my library, if you will, and I pull it out and I can execute it. And then if I need materials, they're identified. Interestingly enough, when companies don't have good bills of materials in their software, planners spend as much as 5 hours a day trying to find parts to do planned work. And so if we can, number one, build the bombs inside the software is fantastic. But in addition to that, for this particular work, we need these parts. And we've got a document that reflects that. And then we just continue that loop. When we have failures, going over here to the red side, we have failures, we have some kind of a root cause. Maybe it's critical events. Anything greater than 2 hours forces our hand on that. We have to generate some kind of root cause action. And the challenge is I was sitting with a group just a few weeks ago, actually about a month ago, I guess, and we were talking about they had to replace a particular component. And they had driven through the process through the root cause analysis side. And when I started looking and digging in, they really had never fully implemented it. And I see this oftentimes, we'll do the level of analysis, but then the real change doesn't happen at what I call the bitter end. The PM doesn't get updated. And like in this particular issue, they really needed quarterly PMs, but all their PMs for this asset were either weekly or monthly, and they never put the quarterly in. And I said, okay, well, how do I know it was to replace a part every 3 months? And I said, well, how do I know that that part's been replaced? Without going back and digging into the system, and most of the maintenance technicians aren't going to do that. They get a PM, they're simply going out and doing it. I said, where's the quarterly PM, as an example, that generates, the activity to specifically change this bearing, on this particular machine. But the challenge has to be is we have to implement those actions, and that's the hardest part, by the way. The analysis, while it may seem hard, is actually pretty simple. The real challenge is actually implementing it to the very bitter end, and then validating the outcomes. Okay? So when we talk about that, think about your world. Do you have a root cause process? Do you have like critical events, anything 2 hours or more? And do you actually determine the root causes, or do you just find the symptoms? And it happens when I was reviewing some of the root cause analysis actions that were done, they simply said, well, the motor failed, okay, and they replaced the motor. Well, that's great, but why did the motor fail? That's really the root cause. The symptom of the motor failure just tells you what happened, and so we need to understand exactly why. And did we do an autopsy? You can take a bearing, for example, provided you didn't destroy it when you dismounted it, and we can look, and you can even go Google images and do a search, and you can find all kinds of images for corrosion or pitting or burnelling or any of those kind of things, fluting with variable frequency drives, for example. Did we actually implement what we discussed? Did we put the actions in place, and did we validate it? And so when you think about that, answer those questions as part of the poll.
Yeah, so let me launch this. This is fantastic. I love this. So I'm going to launch this poll, everyone. Same one. This is our last poll.
Yes.
So let's get excited about it. So we've got, what is your root cause RCA process like? 3 options. First is analysis is done, little change occurs, same failure again. Maybe you're finding training over and over and over again. There's a lot of these RCAs that kind of end up in the same bucket. Analysis of a big event, that next option, some actions are taken, right? And you do see some repeat failures. Or are you more, tracking, you've got analysis, you implement findings, and then the actions are validated, that key step that Jeff was talking about it. So we got about 40% voting so far, excuse me. It's interesting. While we let these folks kind of chew on this a little bit, Jeff, what the wrench time studies that you were talking about, really fascinating. We often talk about improper motivations or alignment, right? And I think when you really get, what that struck me as, hey, when they were going back into the machine shop later in the day, and kind of when you really think about what was really going on there, it sounds like there wasn't a good alignment to just the reliability standard. It was really, they were just trying to figure out just sort of tactically that job, and that sort of keeping the 8-hour workday in scope, instead of really focusing on, hey, let's improve reliability across the system. And I would hazard a guess that happens a lot.
Oh, it does. And as a good example too, even in the same study, at the same location, we would notice that some of the technicians, they had time at the end of every day to put in their time inside the computerized maintenance management system, and talk about all the things that they did during the course of the day. And then it was funny because we would see some mornings that they would go and they would get back into the system, and we're like, why are you doing that? Well, management told us whenever we got a PM that we should actually spend a few minutes and go back and look at the last 3 PMs, the history and what was done. And we said, well, we could have had the planner print that for you. So we asked management and said, hey, you guys asked them to do that. And they said, no, where'd they get that idea from? And so it's not about, see, a lot of technicians get wrapped around the axle with regard to wrench time studies. Oh, they're trying to see if I'm efficient, and they're, and all this. It's actually more so around the barriers and frustrations that they face. And we haven't done a good job. And unfortunately, many companies use wrench time studies in the wrong way. But the goal should be is what is, are the processes working? Are we doing what we said we're going to do? Are we assigning enough work? Are we, are all those different pieces and parts working the way we expect them to work? And if not, why not? And what's creating that barrier and frustration for the technician? That's the game, at the end of the day with the wrench time study.
So true, so true. And on that end, Jeff, the RCA analysis is up. We've got the poll answers back. About a third. That's a big healthy chunk, could improve. Analysis is done, they say, little change occurs, same failure. So that's a big room for improvement. They're about half, 45%, are in the middle there. Analysis of big events, some actions, some repeat failures, kind of middle of the road, right? And then good to see 23% tracking, analysis, findings implemented, and the actions validated. So fantastic.
Yeah, and that's great. Part of that, too, is we talk about it, the defect elimination piece. And that's really, if you think about root cause analysis, you come out with so many root causes, usually it's more than one. And how do you eliminate those defects and prevent them from reoccurring? That's really part of the challenge. And there's a whole nother world with regard to defect elimination, but I'll even mention this, with regard to planning and scheduling, for example. How do we make sure in operations procedures and other things, we've got existing defects in the system? How do we make sure we don't add new defects? And hence comes back to Winston's days domain around precision domain, making sure we're doing things in the right way. Yeah. So that concludes the presentation with regard to what I wanted to share with you today in the time that we have. Obviously, a lot of opportunities, and at this point, we'll open it up to questions that you might have relative to what we've talked about today or anything else.
Brilliant. Yeah, and we do have some questions coming in. The first one came in pretty early, and it was my chat was asking. And this is actually, this is something I have a question about, and I'm not afraid to ask. I love this, Chet. Is proactive maintenance the same as preventive maintenance, right? There's those two words can kind of get interchanged a little bit. I've heard people, even industry leaders, kind of flip back and forth a little bit. What's your take on that?
So to me, no. Okay. And so actually, I go to a different level. And you say, well, what do you mean, Jeff? Well, what happens is that for me, being an RCM practitioner, certified RCM practitioner, we talk about PM as time-based, doing something like a schedule using actual RCM lingo. We talk about PM being time-based, hours, miles, cycles, strokes, days, whatever the case may be, using it in terms of almost like meters, if you will. And we do schedule restoration or schedule discard activities regardless of the condition of the assets. So we say, okay, we're going to restore this piece of equipment. We're going to replace this impeller as an example. Regardless of condition, we're going to do it based on time. And it may, be after so many gallons or so many days or whatever the case. And then when we talk about predictive maintenance is obviously the technologies, vibration, infrared, ultrasound, but it's also more than that. And I actually prefer, rather than predictive, I prefer condition-based maintenance. And condition-based is based on some condition, finding the potential for failure. We're going to take action and correct that issue. And so, for example, that could be, like say, could be an inspection. It could be like something measuring the thickness of a pad or something. And when it gets worn down to a particular point, we're going to replace it. So we're taking action based on that. And then proactive maintenance is more so of approach on how you combine that. And it's how do you combine not only just the PM, time-based schedule restoration, schedule discard with the condition monitoring activities, but it's also how do you think about elimination of the defects as well. And, we talk about different organizations or at different levels, and we often talk in terms of emerging proactive versus proactive, but when we start talking about proactive, it's much more. It's partnerships we talk about. It's predictive tools. It's doing the right maintenance at the right time, for example. So it's much broader. And then you can even get into prescriptive, for example, where you're taking, predictive has never really been predictive. Let's face it. You can't predict for me at 2 o'clock on Thursday afternoon that this particular piece of equipment is going to fail. You can't. The technology is just not there. But as we continue to progress with artificial intelligence and so forth, what happens is we can combine like 60 sensors on a machine, and we can get much more accurate at predicting when something's going to fail, based on previous failures and patterns from other similar pieces of equipment across the world in reality. So yeah.
Yeah, fantastic. That's great. Thank you. So that's very clearly, and so it's interesting. You said the elimination of the defect, and that's kind of important there. So good. We got a couple more. I've got one myself. I wanted to ask you. You're going through that corrective job plan, Jeff. I'm wondering, is there a significant difference to just a job plan, just schematically? When you put one of these together, let's say you're on site with a client, they don't have any job plans, right? You've got a blank piece of paper to work with. Is there a difference between a corrective job plan and a job plan? Is there any differences in your mind?
Not really. Okay. And what do you mean by that? Well, when we think about the job plan, is typically most systems would be something like a PM. And the PM should be written to a specification, and again, trying to find it in the act of failing, that P, or doing some level of overhaul. It's based on some frequency or whatever. But the corrective job plan is really how are we correcting those potential failures. So for example, maybe I need to replace a pump, or maybe I need to replace the inside of the pump, or whatever the case. Well, what are the steps, the task steps to do that? And we think about it, just like in a regular job plan, you've got your safety aspects, you've got the duration, the time, the tack time, we could call it from a lean perspective. You've got a description of it. You've got the number of personnel that are required. You might even have children that break that even further, in a parent-child relationship. But the point is that now you've got the task steps, and the task steps are written to a level of precision. So in other words, set the torque to be this, or the gap to be that, or whatever. And then, you've got your material list, and, you might have other things like consumables, for example, if you have to travel some distance to, don't want people to forget something. So it's very, very similar. The difference is the PM, obviously, the job plan is triggered on some frequency, either using meters or time. And then the corrective job plan is only triggered when that work needs to occur. See, so that's really the difference. As a matter of fact, in one system, they call it an unscheduled PM.
Got it. That's interesting. Okay, good. Thank you. Well, I've got one last one, and then I'll have you switch to the next screen, Jeff, if you would. Wanted to make sure everyone here understood and knew some of the various certifications for maintenance people out there. Just kind of set a step for, hey, here's some more things you can do for certifications, and I know that you all help in that category. So first, would you advance to slide 1? I think there might be one more, and then what kind of certifications are out there?
Yeah, so with regard to that, the certifications are, for example, you have the Society for Maintenance Reliability Professionals, the CMRT and CMRP, Certified Maintenance Reliability Technician. I'll share with you, we offer a class for that. It's a 3-day class. It's an outstanding class, very high pass ratio. Then we have, the Certified Maintenance Reliability Professional, and that's by far the leading certification in the world for maintenance reliability practitioners. And then with regard to, there are other organizations, for example, like the American Society for Quality offers a Certified Reliability Engineer certification, which is a lot, not just a broke fix scenario, but like product design as well, and not just the maintenance of assets is the way I should say it. And it's very good. There's a lot of statistical analysis and other things relative to that. Obviously, from the University of Tennessee, we have the RMIC, Reliability and Maintainability Certification. You have the, we talked about planning and scheduling. We talked about storing materials management. But the benefit, there's just tons too, for example, on all the predictive side, infrared, ultrasound, and so forth. Lots of certifications, lots of different certifying organizations. One of the big ones that I think is really important in many organizations that often overlooked is a machinery lubrication technician certification, because we have so many failures that come from improper lubrication. So there's a heck of an opportunity there. And then get people certified and have them come back and lead the program and teach the rest of your organization. It's a really key piece. And so that's where I would say, there's just lots of different ones that you could find. And you can always chat me up on, send me a note on LinkedIn, which we've got here referenced, and, I'll be happy to share some with you or discuss more with you with regard to that.
That's great. You're also on Twitter. Please go visit peopleandprocesses.com, everyone. Fantastic stuff. Go get the book too. I'm going to go check that out. So I really appreciate it, Jeff. One more slide, and then we're going to wrap it up here for us. Jeff, if you would go to that last one. So across the board, all of our customers, everyone we talk to right now, there's a bit of a labor issue going on, and there's a couple of resources I wanted to point you to. We do have a guide now that kind of outlines how plant management software does mitigate some of these risks. Some of the things you were talking about earlier before we started the podcast here was, OEE. There's a lot you can do there. QMS, right? SPC is huge. How do you reduce waste? How do you do these things so you're getting more out of every hour? But in any case, I really appreciate your time today, Jeff. Very nice to get to know you. Really great working with you on this. And I again, tremendous work. Fantastic. Thank you so much for being with us on Beyond Compliance.
And thank you so much for having me. I really enjoyed working with your audience.
Yeah, all right. Well, that'll wrap it up for us. Thanks again, Jeff. I'm going to be looking for you. I'm going to link you up too, Jeff, and I'm going to start looking at that show in Orlando in July that we were talking about. I hope to do some more things. You got a fantastic team with you. Appreciate Tammy and all the folks on your side helping out, and we wish you all the best there. And then that'll wrap it up for us, Beyond Compliance here. Take care, everyone. Cheers.
Cheers.